Welcome to Technorazzi. I'm Dirk Dusharme. Last week we met with John Hammond, president of Indicate Technologies here in Silicon Valley, California. John demonstrated the capabilities of a Metrosystems laser scanner. This week, John shows us a vision multi-sensor system by Optical Gauging Products.
Well, today, Dirk, we have the SmartScope Quest 250 by Optical Gauging Products.
Is this the one with the really tiny little probe on it?
It is.
No, I definitely want to see that. Let's go take a look.
One of the unique things about the Quest is its optical system. The Quest, SmartScope Quest, does represent the high end of the Optical Gauging Products offerings for general purpose vision and multi-sensor systems. It's a fully telecentric relay zoom lens.
What does that mean?
Well, for us dimensional measurement guys, what it really translates into is that it's harder to make a bad measurement.
So this is multi-sensor again, is that correct?
This is also a multi-sensor system. The SmartScope product line is all general purpose multi-sensor systems. The sensors we're using here today will be the vision system as well, going through the telecentric relay zoom lens. In this case, we have another type of microsensor. It's a contact microsensor. It's, you're probably familiar with the traditional Renaissance style touch probes that go on a coordinate measuring machine. Yep. Well, it's like that in that it has a ruby stylus hanging off of a stem here, and we're going to go around and make contact with the part to acquire data, but the technology behind it's quite different. This particular one is called a feather probe, reason being that it has an extremely light touch.
Okay, how light?
Down to 1 milligram of gauging force. The stylus itself is oscillating at a very high frequency, so it's an excited stylus rather than just a static stylus. And as that stylus is vibrating and comes into proximity to a surface, the surface disrupts its vibration and changes the frequency, and that change in frequency triggers a touch probe. We can do crazy things like measure the edge of a feather or profile a drop of water, you know, with a contact sensor. So this ability changes the way that you think about what you might want to use a contact sensor for. So the touch probe may be important in order to acquire data that can't be imaged, such as down inside of the sidewall of a bore. But you still need to be able to get down into it. So that's where the feather probe may also, not just the light force, but also the tight quarters of operation.
Or this looks like you actually have got some sort of precision machined part on your stage here.
This is a medical part, and it's an implant. It's part of a femoral stem for an artificial hip. So this is the actual part, and it has a conical seat here with a center bore. Let's see that. Some of the things we're measuring are what looks to be a cylinder here is actually a cone, and what looks to be a cylinder on this side is also a cone. In this particular application, the angle of orientation of those two cones is important.
So show me what happens with this particular part.
What we have here, a program that uses both vision and the feather probe. We'll just ask the system to run this inspection routine. This is autofocus and grabbing some edges here with the vision system.
So the vision system is doing a 2D measurement?
Yes, it is.
Okay.
Now it's interesting that you asked that, because vision systems are also capable of doing 3D measurement, which many people wouldn't think. Typically the way you'd acquire the third axis is through autofocus.
Measuring how far the focus mechanism is having to move?
Yes.
Okay. But I noticed the vision part is stopped. Is it taking probe measurements now? Is that what's...
Yes. So the SmartScope systems will allow you to switch back and forth between sensors.
And from this, I'm assuming it's going to be able to measure the roundness of the cone. Is that part of what it's looking for?
Actually, we call it conicity.
Conicity. There you go.
So one of the things that the SmartScope Quest platform allows us to do is use multiple different sensors to acquire the data, whatever sensor is appropriate, and then do the analysis. But when we're doing the analysis, we don't need to necessarily be concerned about what sensor the data came from, because no matter where we collected the data, all this data is maintained relative to the same reference frame, and therefore we can analyze away with confidence.
Now this may be a novice question, but you used a vision system and a probe. why not just put it on some sort of laser scanning machine and do just a laser scan and capture a point cloud of the whole thing and be done with it?
Typically, the answer to that is driven by, primarily, is what are you trying to accomplish? So concerns here might be for throughput.
Being a novice at all this, I just assumed that a laser scanner was actually probably the most general purpose type sensor you could have. I mean, you could scan anything, right?
When you're doing something optically, you have to get energy transmitted and energy received. As long as the geometry of the surface lets us do that, you can imagine that if the laser light is being transmitted at a certain angle and being received over here, if we were going down into a hole, as soon as that laser light gets blocked, suddenly we can't get light down into the hole and back out. We're trying to match the customer's needs with a solution that meets a lot of criteria, both technical and commercial.
Okay.
And environmental.
Yeah, well, thanks. Well, so this has been the Smart Scope Quest with both vision and touch probes.